This is going to be the rest of your notes in your notes packet. After you watch the video and have tried a few things, if you have trouble still. So this question is asking if these numbers are in the solution set. So you just plot the point. So I'm going to plot this point 2, 4. If it's there, I just say yes. If it's in the shaded region. Negative 2, 2. That's right on the line. And since the line is dashed, I would say no. Negative 2, negative 3. So we're down here. We are below the line there. So we'd say yes. For this one, you can plug in the points for x and y and see if you get a true statement. Or you could graph the line. I'm just going to plug in the points. So 2 times 2, negative 5 times 3, plus 8. So I'm answering the question, is 4 greater than or equal to negative 8 plus 8, which is 0? If that's a true statement, 4 is greater than 0, then I would say yes. Same thing on this one. I'm just going to plug in my 2 points for x and y. So I get negative 3 less than negative 3. It's not a less than or equal to, so the answer there would be no. Okay, so just like before, closed circle was an equal to open circle. So the same thing is true with linear inequalities. It's a dashed line. If it's less than, if it was less than or equal to, it would be a dotted line. Okay, so let's graph these inequalities. Graph them just like you graph a regular line. So I'm going to start at negative 4. My slope is 1/3, so I go up 1 to the right 3. And the line is dashed because it's not an equal to, it's just a less than. And if it's less than, I shade under the line. I make these lines going down from the line, and that would give me my final answer. For number 2, I need to solve first for y, so I can get it in slope-intercept form. Divide everything by 3. So y is greater than negative 2/3 x plus 4. So I start at 4, down 2 to the right 3, just make sure I'm negative. It's greater than, so it's dashed. There's no equal sign. We're not including the line. And since it's greater than, I'm making lines going up from my line. Y is less than negative 2. So that's a vertical or a horizontal line through y equals negative 2. That's how you can remember to do it. It's dashed. Again, follow your rule. Everything below that line, since it's less than. This one is not solved. I need to solve it first before I can graph. So you can pause the video and put it in slope-intercept form. I'm dividing everything by negative 2. Now, my one rule of inequalities, if I divide by a negative or multiply by a negative, I have to switch the inequality. It has nothing to do with the other side. The other side is just dividing those out. So I switch the inequality to greater than. So I make a point at negative 3. And I want to go down 5 to the right 2, but I can't. So I'm going to go up 5. 1, 2, 3, 4, 5 to the left 2. So I'm still negative. I'm having trouble making my points. 1, 2, 3, 4, 5. It's dashed. That's a terrible line. Greater than, so I'm making my lines going up from my graphed line. So I know what to shade. That tells me to shade above. I need to solve for y. There's a negative 1 there, so I'm going to divide everything by negative 1. So that means I change my inequality sign. So I'm going to write this 1 as a 1 over 1. So I remember the slope there. So I make a point at -5, and I go slope of 1. So I'm going up 1 over 1, dashed. Less than. So I'm graphing under the line. Number 6, subtract x. Divide everything by 5. I did not divide by a negative, so my inequality stays the same. I'm going to write this as a fraction. So -3, down 1 to the right, 5. Up 1 to the left, 5. Dashed line, because it's not equal to. And I'm going to shade under, drawing my lines, my vertical lines from the line down. And so these are just some more practice problems, kind of a final practice here, where you're going to solve for y and put it in slope-intercept form. So -5x and right here is a important place to stop and look. I'm not going to divide by a negative, so I know nothing's going to change. So my final form is y is greater than or equal to -5/2 x plus 4. So what do I know? I know it's a solid line. Greater than means I'm going to shade above, and then I can graph my line. So I make a point at 4, and then I'm going to go down 5, 1, 2, 3, 4, 5, to the right, 2. I'll just double check to make sure my slope is negative. Solid line, and I'm shading above the line, so I'm drawing my vertical line. So it's going to be all of this. Once you do a couple of them, you can tell where they're all at. Subtract 2x. Y is less than -2x minus 3. So it's now in slope-intercept form. It's a dashed line because there's no equal to, and it is below. So I make a point there at -3. The slope is -2 over 1. So down 2 to the right 1, up 2 to the left 1. We said it was dashed, and our lines are going to go above this value. This is a special case. X is less than or equal to 4. It's already in the form to graph. I know it is a solid line, but this above or below thing is kind of tricky on this one because x equals 4 is a vertical line. So there's no above or below, but it says less than or equal to 4. So everything that's smaller than 4 would be to the left of 4. So I'd be shading over here. Okay, the other special case, if this said y is less than or equal to 4, y is a horizontal line, and if we would shade everything below it. So it works for the y, it does not work for the x. X is the one special case. Number 4, minus x minus x. There's a -1 in front of my y, so I divide everything by -1. Flip the inequality because I divided by -1. So this is 1x minus 4. So it's a solid line because of the equal sign. It's above because of the greater than. So I graph my line, -4, a slope of 1. Let's make a few points. 1 over 1. Solid line. And because it's greater than, I'm going up from the solid line. So all of this area would be shaded in. Okay, so kind of getting back around to the last reminder of how you find a solution. You can graph it, but it's easier just to plug in the points. I'm plugging in 0 for x, 0 for y. Is 0 greater than 5? That would be no. Okay, so you're just plugging those in. Be careful because greater than, if you get 5 greater than 5, you know it's not true. There's some more that you're going to go ahead and finish. When you look at these problems, just know, like right away when you look, you know you're going to be dividing by a negative. So you're going to be flipping the inequality. Right here, I'm dividing by a negative, so my inequality is going to flip. I know I'm going to divide by a negative there. So you can kind of check ahead of time and see what happens there. All right, so that should help you finish up that paper and get started on your project.